In this tutorial, we will look at processing optical and curved data in the Spectrus Processor environment. We will start with basic processing functions. Drag and drop support is available for most data types. Here, we will take a spectrum from our recent file list and drag and drop it into our viewing window. Spectrus Processor contains many standard processing features. We'll cover the major ones in this session, starting with baseline correction. First, let's close the structure editing window by clicking the X and disabling the display of peaks and annotations for a clearer view of the spectrum. Baseline correction is used to correct a slope or offset in the baseline. This is useful for making good-looking spectra for reports and to improve quantitative results when looking at peak ratios or peak areas. To start, we'll go to the Process menu and select Baseline Auto. This generates a baseline across the bottom of the spectrum, seen here in red, which is subject to the parameters set in the Baseline Options menu. One can make changes in the Options menu to change the characteristics of the baseline. The small box following the cursor indicates that we can manually add a node to the baseline. Simply click to add the node. You'll notice the software has automatically added nodes as well. This is owing to the options currently set. If we right-click on the spectrum, we find options at the bottom of the menu. Here, we see the current baseline options. Some of the key selections are in the Draw section of this menu. Below Spectrum and Snap to Spectrum, both selected, will result in these additional points being picked. The other options offer different ways to treat the data and how to contend with a series of spectra. We'll leave the options unchanged and cancel the menu. We've seen how to add nodes, and we can remove them as well. Right-click and you'll see we're currently set to edit nodes. Click on Delete Nodes to enter that setting, and simply click and drag a selection box to remove all the nodes in that area. Satisfied with our baseline, we'll right-click again to find Subtract in the menu to execute the baseline subtraction. Note that this is still only a display of what the baseline subtracted spectrum will be. We have not yet saved these changes. If the spectrum is satisfactory, we can right-click and select Accept Changes to end the baseline correction mode. Another common process we'll touch on is peak picking. Peak picking can be done manually, automatically, or set to occur when any spectrum without peaks is opened. Navigating to the workflow bar, seen here at the bottom of the screen, we can find peak detection commands. We can click on the Auto button, and it will generate peak selections based on current options. The next button, the Peak Level, produces a horizontal line we can set as our threshold. Any peak below the line is not selected, any peak above is selected. We can also pick peaks manually. Rather than going to the Workflow menu, we can right-click and select Peak by Peak, then clicking on a peak to select it, or selecting an existing peak to deselect it. To view a table of peaks, find the Table View button along the top menu and click Show Table of Peaks. Here, you can see the table denotes the wave number and absorbance value. Current options also display the full width and half height, along with the asymmetry of that peak. If asymmetry exceeds a certain value, full width half height won't be generated. We'll now look at spectral searching. There are 4 steps to any spectral search. First, you'll select your query spectrum, or the unknown. Second, you'll set up the database or databases that you'll be searching. Third is setting up the query parameters, such as what search algorithm to use or a specific spectral range. Finally, you'll execute the search and review your results. We'll start by dragging and dropping a new spectrum into our window. This will be our unknown. To set our database, we'll select the arrow on the Database button. This will reveal a list of databases currently available, as well as enable one to specify a new database by browsing for available ones. Here, we will select the Koblenz database. Selecting the search options allows us to customize the search parameters. In this case, we're executing a similarity search based on first derivative Euclidean distances. One can customize whether to search the region currently being viewed or specify a specific range. We'll select Search. The search returns with the first hit and the query spectrum in the overlay. Navigation buttons are at the bottom right of the screen. The HQI, or Hit Quality Index, measures the quality of the match. You'll notice the background message indicates that we are looking at the first record of 100 results. The HQI, as per similarity search, can also be seen. To see the next record, we'll click on the Next arrow. The structure corresponding to the database match is visible at the top left. Our query spectrum remains in the overlay. There are several viewing options as well. You can toggle the offset by selecting the appropriate button from the top toolbar. We can quickly access zoom options from the right-click menu to get a closer look at a specific region. Our current view will not change as we cycle through the matches. This will allow you to examine the same peak across different hits. To return to a full view, right-click and select Zoom All. We'll now take a look at some of the tools that help us to interpret spectra. We have knowledge bases of infrared and Raman spectra. These will enable us to make correlations between structure and spectral peaks. Working with the same unknown and database search result we generated earlier, we'll start by going to the Interpret buttons on the workflow bar and selecting the leftmost one to enter the Assign mode. With the proposed structure from the database search displayed, we can highlight parts of the structure, and it will overlay on our spectra where it would expect to find those bands. This can give us clues as to what those bands might be. To make a correlation, we can simply control-click on one or more peaks. Once correlated, mousing over either the structure or the peaks will highlight the relationship. In this way, you can make structure spectral correlations and save them to your spectrum. We can also browse the knowledge base. Right-click on the work area and select Knowledge. This window will provide a list of all the fragments that are contained. One can search manually or click on a peak, and results will be filtered to fragments that could best match. Another option is the Verify functionality. This will take the proposed structure, consider its component fragments, and verify whether these fragments exist in the spectrum. In this instance, we are alerted to fragments that are believed to be missing. We can click on the Structure tab for more details, including the specific fragments determined and their status. In this case, we have the methyl sulfone group. One fragment being out of range, the other has not been found. Taking a closer look, we can see that a nearby peak is just out of range. You'll find that verification errs toward the strict. We'll now take a look at some of the basic visualization options, including zooming and how to deal with multiple spectra. We'll start with an empty workspace. Using Shift or Control-click, one can select and open multiple spectra at the same time, again, simply by dragging and dropping. We'll close the structure editing window. Right now we can only see one spectrum, despite having opened two. This is because we are currently set to tile view mode, and we have one spectrum specified. If we increase the number of spectra visible, we can investigate more than one spectrum at a time. Note that spectra are presented in this way because we are in Add New Window mode. Whenever we open a new spectrum, we create a new window for it. Depending on your workflow, you might prefer to use the replace mode, where only one window is used and every new spectrum will replace the previous. Or you can choose to add new spectra into the current window, creating a series of spectra. When using multiple windows, the orange highlight will denote the active window. Any processing would be performed on that spectrum alone, zooming included. If we are looking to simultaneously operate on both spectra, we must designate them as related. To do this, we perform a shift click on the second window and click on the Synchronize button. This will synchronize the x-axes, letting the software know that they are related. Executing a right-click horizontal zoom will now change the views equally. Clicking on either spectrum will produce a vertical line, which is useful for seeing how well peaks align. Let's now look at preparing a series of spectra in one window. We'll clear the workspace with File, Close All. We'll instruct the software to add new spectra to one window, then Control-click and drag and drop two new spectra. As you can see, both spectra open in the same window. Currently, the spectra are offset. We can also view them overlaying one another or stacked. As we are working in one window, any zoom command will affect both spectra. We will start by dragging and dropping a spectrum into the workspace, which will initiate an ASCII import dialog box, since the majority of thermal data is kept in this format. Here, one can specify the x and y axes. The thermogravimetric analysis tools can be accessed through Analyze, Thermal, TGA path. We'll use a rectangular zoom to focus on one section of the curve. Having initiated TGA mode, we can proceed to select our lines for analysis. The software will offer a straight line upon mousing over a given section, or we can click and drag a box over the curve to generate a linear regression. We'll do the same for the bottom, and the software will provide the onset, endpoint, midpoint, and delta values. If we take a quick look at our options, we see that we are currently using half delta as our midpoint. We can also use the inflection point. The View tab in the Options menu allows you to toggle which labels you care to see and how they should read. We can access differential scanning calorimetry tools in a similar fashion. Analyze, Thermal, DSC from the top menu. In DSC mode, we simply select 2 points to create the baseline, and the software will determine and label onset and enthalpy.